Hi, this is Nathan Tintle. In this learning goal video, we will discuss how to implement the 3S strategy to compare two means. We will use the bicycling to work example data set to talk about this learning goal. Remember the 3S strategy: statistic, simulate, strength of evidence. Let's take these one at a time. The statistic is a single number which summarizes evidence for the alternative hypothesis. In this case, one choice of a statistic is the difference in the two observed group means. We can find the difference between the amount of time it takes him on the carbon bike and the steel frame bike and get a difference of a little over half a minute. Moving to the simulation, we're going to write one commute time on each slip of paper and shuffle and deal those slips of paper into two piles. So I've got 56 slips of paper, commute times written down on each slip. One commute time per slip, shuffle and deal them into two piles, one pile with 30, one pile with 26, because that's how many commute times we have in each of those groups in the real data. Find the difference in group means between the shuffled and dealt piles and repeat that many, many times, each time finding the difference in the group means. We then get a histogram of 1,000 or more differences in means that happened when the null hypothesis was true. This distribution is centered at 0, as we expect it to be. Now the question is strength of evidence. How often is our observed statistic, that's the negative 5.35, or more extreme, occurring in this set of simulated statistics? We're going to do a two-sided test here, so we're going to count samples beyond negative 5.35. That's less than negative 5.35, greater than 0.535, and we get a p-value of 0.729. This means we do not have strong evidence that the average commute time is different between the two bikes. A couple of words of caution: the statistic is a single number. It's the difference in the group means. In the 3S strategy, that first step statistic is always one number. And secondly, which group you subtract from which doesn't matter. Notice our statistic was negative 0.535. You could just as easily have used positive 0.535. Doesn't matter. You just need to be consistent. Whatever you do when you compute the statistic, do exactly that same thing when you do your simulation.